Welcome to Pulse of Tech by SEAP, Pune's leading technology podcast from SEAP, the city's premier platform for tech organizations, delivering cutting-edge discussions and insights.
Most of the home appliances in India have not seen a major change in the past decade. But our current guest decided to disrupt the most common one, the ceiling fan. Coming from an elite robotics lab in IIT Mumbai, Manoj Meena has been obsessed with frugal engineering. That is the art of building something more from less. What started in a chawl in Mumbai has resulted into a 1,000 crore brand and a state-of-the-art factory and R&D center right here in Pune. Please welcome the founder and CEO of Atomberg, Manoj Meena, who by the way has been receiving his birthday present from the President of India for the past 3 years. Good morning, Manoj. How are you?
Good morning, I'm doing well. Thank you for inviting me here.
Glad to have you here. So Manoj, I wanted to start with a very, let's say, a personal question that you grew up in an agricultural background family, right? And from there to deep tech in engineering, right? How did this journey go, building robots in the college and going to the deep engineering background?
It's a very beginning. Since my childhood, I was super keen, or I would say curious to create stuff. And during my early days, I was breaking a lot of stuff. For that, I was often scolded also by my parents. So I born brought up initial years in my village. Mm-hmm. So there, I got an opportunity to play with sand. There was no other option. I was building a lot of toys from sand, and then I pursued my schooling from Jaipur. There again, I continued this passion of building or creating stuff with my hands. I used to, do projects for other students, other friends, not only for my school mates, but also guys from other schools. So I built that kind of rapport that I'm a techie who can build stuff with hands, and I was enjoying it thoroughly. Then came college days. In college, I again pursued this passion, shaped it really well because there were better resources, surrounded by very good people around me, mentors and guides. And since my first year, I was participating in competitions, and these competitions are more organized. They would invite a lot of students from different colleges, and there would be a very well-defined problem statement. So since my first year, I was participating, and it was like a festival to me. Like I was preparing for these competitions 1 or 2 years, 2 months in advance. Doing lots of iteration, and these were all teamwork. So wonderful opportunity to interact with other techies in the college, and I was borrowing money from my friends because you have very limited budget for these. And I continued it for throughout my last final year. And not only in my college competition, I was participating in outside colleges. And luckily, we were winning also. So winning is important. We were winning, and that was boosting our confidence. Mm-hmm. And so it was a continuous learning, continuous fun, confidence boosting. And then during my final year, because we were about to graduate, and it was little important for us to identify what to do next, because we are at the end of the day answerable to our society's parents and everyone and peers. But one good part is that entrepreneurship startup was something which just started during our college. Definitely, we had the incubation center as well. So I got some sense that what I could do as a career option, and I was placed in ISRO as a scientist. And people in my family, everyone wanted to go for a government job, and they were super excited for that. Nobody has into business in my community, so I thought that it would be really difficult to convince them. And that's how the journey started from childhood, and I got into engineering, robotics, and then finally pursued, and I'm doing this today. Luckily, I feel myself very lucky.
Yeah, one of the questions which I wanted to ask you was when you got an offer from ISRO, right? And government job was the first thing which anybody would have spoken to you about, right? So, what was the toughest personal
sacrifice or a conversation which you had to have with your family or anybody around who, as a matter of fact, what was the toughest part of that?
It was difficult to convince that alternate career as a startup exists. It was really difficult to convince my family. So I didn't get into the tough discussion. I lied to them that I have got an extension from ISRO and I can join back ISRO after 1 year. And I assumed that in 1 year a lot of things will change and I will do some magic and they will be convinced.
So negotiation came from there itself, right?
Yeah, I like that. Allow me for 1 year experimenting. And they allowed. See, they were always supportive. The worry is they are always worried, you are now graduate and you should do something and do some job. If not, then why don't you go to studies for UPSC? A lot of people from our colleges also used to go to UPSC preparation in Delhi. So that was also one, wish list they had. They wanted me to go. So I got 1 year, leeway, runway to do something, experiment and come up with a better logic to convince them.
Nice. I've heard that Attenberg also has a very quirky let's say, story. So before we get into the technical or nitty-gritties or anything, I wanted to understand how did that journey begin for you?
I always wanted to be in this field.
Okay.
Associated, myself with like doing the techie stuff, building things from scratch. And in my final year, I made up my mind that I should continue this thing. And the startup could be a good opportunity to be part of that. And see, as I grew up during my college days, I built some sense of belief and mission purpose, because that is really important, because these are very risky and bold calls in anyone's life. Right?
Totally.
So you definitely need a hidden deep purpose. Then only you can take these bold steps. So I was able to build certain deep purpose or mission statement, I would call it, and I'm still living those core mission elements today, and that is helping me to take tougher calls. Not that time, but every year we end up taking certain tough decisions around product, around team, around what next. So one of the core mission is that being an engineer and from technical field, I strongly believe that engineers should solve for people. And in Indian context, I strongly believe that Indians deserve better lifestyle, better experience.
Correct.
And you can deliver that experience and lifestyle by solving something technically. It would definitely be a tougher problem to solve, right? All the product which people are using in home appliances or outside home appliances, people have more aspirations, right? In today's world, and the aspirations are going to go up all the time. It's just like that. As an engineer, we need to understand those aspirations of common people, break it down into an engineering problem statement, and then solve for it, right? So this is one purpose mission, and nation building was always, back in the mind that we should do something out of the box from India, from that make nation plan. And most of the engineers think about it, and so that was always there. That why don't we do a high-tech stuff in India and make India feel proud? So these are few, core elements which I was trying to discover how we can do that, or what we can do that. Yes, that was the core element, and I always have the realization that if some of us don't take that bold call, then who will do it? Right? And they were definitely lesser example at that point in time, but today we see a lot of startups, doing a lot of examples, a lot of success stories. I'm very happy to see the guys doing what they are doing.
Okay.
So I now go more deeper. So I told you, how the mission was there, and the purpose has to be there to take tougher call. I took that call in my final year, and then I was hunting for the name. I was very excited. It was very exciting, exercise to come up with the name. So the name was conceptualized at Attenberg. And then after graduation, I, along with my roommate, he was my partner in this journey.
Okay.
And then my colleague from campus, we shifted outside in a job with a very limited budget. And some of our friends who got good jobs, so we told them that you have to fund us. and you cannot say no because you are getting the salary every month. So we were able to arrange some funds from friends and family, very limited fund, shifted just outside IT campus in a job, and started our activities.
Okay.
Right? And to survive, because survival was very important, and that is, I would advise all the entrepreneurs that if they're able to identify some mean of surviving, then they will get more breathing space, because at the end of the day, whatever you try, the chances of success is limited.
Very.
There might be a lot of failures. So only if there is survival mechanism, it will help you to stay longer in the game and experiment more. Maybe one product, two product, maybe third will be successful. So we started this journey, took projects from research laboratories in IIT, from other colleges. Some projects we did for ISRO, BRC, DRDO. And that's how the journey started. And these projects were into data acquisition system. That is one device we were building during those days, where you make this device, it has capability to collect data, the technical data, for example, temperature, pressure, voltages, or current, which will enable research scholars to conduct their experiment, log the data. There was an application also we built at that time, which was acquiring all this data on the system or on a PC and creating those .csv files or Excel files. So that was our first project.
Okay.
That was our bread and butter.
Okay.
Right? That enabled us to think more what more we can do, what we can identify to scale it up. And it was a journey of many failures after that, because as I told you that 1 year nothing happened. We were in a more worst scenario financially, and my partner also had to leave because he left
do something
for UPSC exam.
Okay.
And he is very successful in his career. Of course, he wanted to pursue that choice. And so that was one setback for me, because I was alone again in my journey. And then again, almost 4 ideas failed in next 3 years. So I graduated in 2011. Till 2015, I would have experimented, say, 5 ideas from data acquisition systems, remote data logging, vehicle tracking system. We did some projects for Amul, Mother Dairy, Domino's for their cold storage monitoring. That also we were not able to scale. And then some projects we did for shop floor monitoring, for factory machine monitoring. For some, again, these were projects. Nothing was a scalable product. And a few things we designed, like gas analyzer, flow meters. So it was, I would say, not failure, because I was learning. Our team was learning. We got good learning around electronics, hardware design, programming, software development. But yes, the idea was still missing. And as I said that there would be many failures. But if you have a survival mechanism, that we were doing these projects very often. One project you were able to survive in 1 month, another project 1 month. So that's how it was giving us more breathing space. In the whole journey, I was also able to assuring my family that something better will happen. I'm doing well, and there is no need to worry. And we were incubated at campus also, so I have to also convince them that one idea after another idea, they were saying that you are pivoting from one idea to another idea. It was a kind of trend. And whenever I was kind of visiting them, they would be knowing that I'm coming up with a new idea. So that's how the journey, was continuing. Finally, Shivam, he is now my co-founder.
Okay.
He joined me in 2015, and he was also my hostel mate, and I knew him for a very long time. He was having his own failure of journeys of failure, like running his own startup in e-commerce and few more failures. Finally, we came up accidentally, to build the fan, and there is a very exciting story behind it. So it was 2015, and it was a Sunday afternoon, and we were lying on the floor because there was no bed. we were roommates also, by the way, in the shop. So
somehow I know this story. I would want to hear it from you.
So we were arguing that who will turn on the fan, right? And we were saying that you should do. I was saying you should do, and then we realized that can we make the fan smarter? Can there be a remote? And that's how the one opportunity came, that can we make these home appliances smarter, right? And again, it was falling in that mission that we can improve lifestyles of people, create impact in millions of lives. Okay. Very small hope. With that hope, I took that hope very seriously because there were very limited hopes, right? So we experiment many ideas. And then I decoded what people have been doing in fan for the last 100 years, if you see. No innovation. The technology is not 10-year-old, it is almost 50, 60 years old technology, which most of the fans are running on. Making them smart was one problem statement, but the bigger problem statement was that they were super energy inefficient.
Yeah.
They were highly inefficient. Right?
Okay.
So then we build a very small business model that there are more value proposition, more USP if we make fan smarter, make fan energy efficient.
Okay.
And there would be definitely buyers of this product. And identifying those early adopters, our initial customers, is going to be very important for us at that time. And because it was a high capex, it was not just like that you do one project and
Correct.
survive.
Yeah.
It would demand a lot of capex, tool infrastructure, manufacturing,
Which we see in here.
it is so it would be a huge commitment.
Whatever you are saying, I could see it in the design which I am seeing here. Like when you said that we wanted to do something, it was like one quote which stuck by me when I was walking the passage where it is written, "The time is always right to do something right." So I like whatever you are saying, I can see it in the entire office which you have here.
Yeah.
So yeah. Anyways, great. I mean, it's a great journey to know. And I see that you were talking about the name. How did the name came from?
The name, today I can make a meaning of it, and I have created a meaning of it. But that time, it was a mix of suffix and prefix. It was an exercise. I was identifying name, and I wanted to start with A. Right, because in my college, people starting with name A, they used to, yes sir,
The first
present sir. So I thought, yeah, if there is a list of companies, at least we can.
We go on the top.
So the reason for A is that, and atom was one of the prefix in the list.
Okay.
And Berg was another, like one of the suffix in the list. And it was mix and matching. And idea was to identify a word combination which sounds cool, which sounds techy, which depict technology. Right. So Atomberg was then conceptualized. There was 3-4 names in the list, and then I already made up my mind that Atomberg is the right name.
Yeah.
But still, I conducted a call with my friends, whom I'm going to take money, right? After the admission, that you are also part of the journey. You are also supporting.
Yeah, you gave the name.
So why don't you select one of the names, right? So there was a list of 4, and Atomberg was the least, last on the list. But I told them that Atomberg is the winner. So that's how the name came. And early days, today it is very much easy to pronunciate because people know about it.
Correct.
The brand is known. But that time a lot of people were calling it atom bomb. Right? I've been doing cold calling in some of the colleges and some professors, some scientists that we are doing some stuff like that. Would you be interested in data acquisition? That's what the requirement. I'm calling from Atomberg. So yeah, atom bomb. So those were the days. And so that's the story. But today, like we are able to make a very strong meaning to that name, which is amplifying our purpose. You know, and so in that context, atom represent very small, tiny idea, and Berg is the mountain, the little meaning, and Berg is a larger problem statement. Okay, basically solving large problem statements with small ideas is the essence of atom.
Awesome. And you have a very good name for your employees as well. You call them atomites, right?
Atomites, yeah. So people who are solving these problems are atomites.
Awesome. This is, I mean, really cool to hear this also. So, Manoj, your success today is deeply rooted into technology, right? And I can see it here. As a founder, CEO, the kind of testing equipments which I saw right from Pelican testing to reliability testing to performance testing. I mean, I was intrigued to see a lab where people are actually using it to see the effect of it, like a juicer to actually using fruits to take out juice to see the consistency of the juice or something like that. So I mean, what is the mantra of an atomite which you instill into your R&D teams, which makes Atomberg?
Yes. See, one of the key success, when we see we are successful, we always see that are we able to fulfill our mission. So a lot of things here start with the why we exist, why we are doing whatever we are doing. There should be inspiration and motivation, not only in myself but every individual, all core team members, all the engineers who are working here, which is much bigger than the individuals. The mission statement is very clear that we are here to solve problems for people, and for that you need to identify what people are facing, what problem they are facing. So we need to interact with them, understand their aspirations, and when we reach out to consumer, if we ask them that what you want, we will not get the right answer. It is an art actually, to people say that you should know more about your consumer.
Yeah.
So basically, we definitely spend a lot of time with our consumer. We interact with them, but our objective is to understand their aspirations, to get into their lifestyles, to get into what kind of experience they are lacking, and how we can create a meaningful impact in their lifestyles by launching better products which are delivering better experience. So that's how we conceptualize each and every product journey, and that's how things start, and what we are trying to solve for them. In case of fan, we knew that energy efficiency, not many people actually are aware about how much power consumption a fan consumes, right?
Yeah.
It is people are okay that what is true, we consume 28 watts power, other fan consume 78 watt power, but it doesn't generate any feeling to them. They just get that we are using some energy efficient fan. Maybe larger aspiration was they are looking for more aesthetically appealing smart fan, right? And their imagination of smart would be very different, right? Today we say that EVs are smarter than the gasoline.
Yes.
But you will see that a lot of design language has changed. Integration with smart interfaces, LEDs, color, material, finish. A lot of things have changed, and there is a better experience when you're driving those cars. There's lesser sound, lesser vibration. So all these things create a difference in people's lifestyle. Right? So definitely think we'll start, what we are trying to solve from consumer first. Then decoding that aspiration into engineering problem statement, that what is smartness for them, right? For them, smartness might be a sleeker design, fan which depicts modern aesthetics, modern color, materials, better interfaces, like remote control we introduced, better LED interfaces we introduced below the fan, made the fan more compacted in nature.
Okay.
So now that is the engineering breakup of that aspiration, that we need to do something like that, right, to meet that aspiration. Now think is how we are going to do that, like how technology is enabling to that. So technology is coming much later in the journey, right?
First, understanding the consumer is more important. Then the technology bit of it comes in.
Understanding consumer ask and aspiration and breaking it down into small pieces of engineering,
Okay.
like how the product would look like, which will meet their aspiration.
Okay.
In our case, energy efficiency was it was not solving their key aspiration. It was primarily around aesthetics. For example, your induction motors consume around say 70 to 80 watts power, and most of the power is wasted into heat. And you cannot touch those motors directly with your bare hand because it will be hot.
Very hot.
Right. So it is nothing but a wastage of power, and that's the reason you have to build these motors very bulky. Use aluminum casting or sheet metal casing to take care of that much heat.
Okay.
But those were not a scenario when we introduced the VLD motor. As I said, energy efficient. It was energy efficient, 75 watt versus 28 watt. But it also means that the power dissipation in form of heat will be very limited.
Okay.
So in our scenario, there is no heat. The motors we can make would be super compact in nature. So we made super compact motors.
Which we can see in your fan.
You can see that from 2018 we introduced this product,
Yes.
right? And we again reach out to consumers and distributors. And if we ask them that would you like to have a small motor fan, they won't say small motor fan. They would have said that we need a
Beautiful fan.
beautiful fan. Right? So we decoded this with technology that we have to make design minimalistic and modern. So compact motor was the challenge, engineering challenge to arrive to that. So we then I would say we leverage this BLDC motor technology to make the motor compact.
Okay.
But why to make motor compact? Again, to meet the consumer.
Meet the consumer.
It drives from the consumer. Similarly, we integrated electronics within it, made LED interfaces, beautiful LED interfaces, made the product more smarter, like IoT enabled. You can control them from your app. You can command them remotely also when they from your house. You can reduce the air cutting noise. Also, we introduced few more variants after that. That we want that consumer is looking for lesser noise, lesser air cutting noise. At speed 3, you're gonna talk over phone. So there is a need of, and that is the experience basically. So we got into airfoil design for our fans. We then conceptualized these kind of things. So it has been a journey after another. So this is one thing which is non-negotiable, which you asked that what we believe strongly, that we believe that we need to serve consumer. And serving consumer will definitely demand a lot of problem solving. And you solve these problems from first principle. So that is one fundamental core. Like solving the problem is going to be tougher. But yes, one guiding principle I would say is that you think from first principle. Like in case of BLDC motor, it was less power consuming, technology. And we are solving for modern technology. So can we make it smaller? If there is not much heat, so from first principle it looks like that. Let's make the motor as much as compact in nature. And the electronics can also be integrated because heat is not there. So you can integrate the sophisticated IoT, electronics, LED interfaces in a very compact space. And not only that, you can use a different material. Why use aluminum die casting? So we introduced the plastic diffuser, which is a transparent, and you can see the LEDs from that interface. So it looks modern.
Yeah.
Right? You can see in most of our products powered by an intelligent interface. So that is giving a sense that I'm smart, I'm alive, I'm not dumb device. You can see it, right? So,
Yes.
So consumer was not telling us. The consumer had that aspiration. They have this aspiration that it should look modern, it should look beautiful, and that's how we decode it.
Yeah.
But again, always solving from first principle has been the key. We ask our atomites that we need to think differently. We need to take risk. We need to challenge. We don't need to copy what other guys are doing. So the first thought process is not easy actually. You have to convince your team that you have to remove all the baggage. Many times we hire people who are coming from the other industries. They're coming up definitely from their own baggage and their own thought process. So we tell them that we know what consumer problem is, and we need to think from scratch. Then only you can come up with the right solution. Otherwise, there is no way, no shortcut. That's the only way that you have to think from first principle, forget everything, and build from scratch. So all these products, you will see that the originality is there, the newness is there, and we have not struggled. I would say that's the recipe.
I can see that in your design principles as well. I mean, the testing bit of it, right? Like knowing the consumer or decoding what the consumer really wants is, I think, is the art which you are teaching atomites here, right? So
we are learning every day.
So you spoke about BLDC motor, right? And that was one of the most important points which I wanted to talk to you today. I mean, that's Atomberg's core disruption is the BLDC motor, right? And you paired the hardware with the proprietary AtomSense algorithm as well. So, which out of these, one is a hardware motor and the other one is a software principle, right? So, which out of these is, let's say, out of these is the difficult part to tackle out of them? Because I am coming from a software background who is very intrigued to.
Yes. I would like to answer it very differently because definitely our journey started with differently in terms of other products than into fan. Fan was easier to do because we built a lot of capabilities on motors and electronic design by then already. And those the building blocks of technology enabled us to make energy efficient fan. Right, but motor and electronics were a competitive edge or capabilities back in 2015, 2016. As we evolved, a lot of things have changed. The motor has evolved definitely from generation 1 to generation 6. It is a continuous journey. And as your mechanical motor is evolving, your supporting electronics and the firmware has to also evolve with time. So there's a marriage between these two things. It has to be packed together. Whenever there is a new motor generation, like for example, we have these products are running on generation 6, right? So electronics has also evolved with this generation. Definitely there are different teams who are building these capabilities continuously, having their own challenges. And challenges are different. Like in generation 6, we wanted to optimize the cost because we again believe that we are there to serve people. It should be affordable to most of the people. Right? If it is not affordable to 70-80% of the people, then it's a problem. Then we are not reaching out the technology and the right and the desired experience to the larger audience.
Okay.
So cost is definitely one challenge which we have been facing, because whenever you are coming up with a new technology, making it affordable has always been challenging. Right? So that's our journey. That when we all came up with generation 5, 6, we always optimized for the design. So the design is easy to manufacture, and these are all mass manufacturable products. We are producing these things in 4 to 5 million scale annually, right? So it has to be mass producible, should be mass manufacturable, and should be cost effective in nature. So the conductor we are using a motor, the chips, the electronics. We have been doing a lot of vertical integration also to optimize the cost.
Okay.
Because our idea is not to increase the cost. We are adding more and more features, but our costs are not shooting. In fact, we want to do more with the same cost. So I think it is a journey of evolution, and I would not say one is easier than the other. They are together. They are born together. And beyond motors and electronics, we have built a lot of other capabilities which are enabling our products, which are making them smarter today and beautiful today. One of the core capabilities we have been building is around the interfaces.
Okay.
So you see these interfaces, there is a lot of research around the material which you have to use, which can diffuse the light very seamlessly.
Okay.
And using the right set of LEDs inside it, having the right design, because all these interfaces depicts a feeling in computer. If we make them fancy LEDs, it would look very ugly. Right? So
Aesthetic is also
aesthetic, and how this interface is seamlessly blending with the design language and depicting the right feeling of smartness to consumer are very, very important. So that magic is done by industrial design team.
We saw that yesterday, that they try to make the material first, try to see how that material would perform in different environments or something like that, and then it goes to, I mean, this is the R&D office, right? Then it goes to production. So so learning that why you are doing this is really great to know what is the principle behind it.
But I think so when you are sure that you have to bring better technologies to consumer to improve their lifestyle, then you are not worried about doing R&D. Like for example, we never thought that we will build a very strong laboratory around material engineering. Today we have in the same facility, we have a lab where we are doing the color R&D. Coating R&D. We have a paint shop here, by the way. A paint shop in R&D. Right? And the team keep experimenting what paint and how these paints and coatings will look in different lighting. Right? So we call it CMS, color, material, and finish.
Okay.
Right? And on top of it, blending the light on top of it. The interface. So all these things have been one capability which we have been building. And then you can see in the modern product which I introduced, they are all powered by a very strong interface. And the color material finish combination outside, and motor tech is evolving, electronics is evolving. Then we do a lot of R&D on process technology. We call it process engineering. And whatever we are conceptualizing, right? For example, a new material we are introducing or a new design we are introducing, it has to be mass manufactured. So whenever we are coming up with a new generation of motor, it is altogether a different design. So the assembly line will change. The methods of manufacturing will change, right? All 4M will change. So our process engineering team ensures that the process flow diagram, the right automation is done at right point in time, right testing is done. So process automation and process for manufacturing has been one other core capability which we have been building to enable these technologies at scale. Other major area which you have witnessed here is around whenever you are coming up with a new tech, right, or a new concept, it has to go through a sophisticated reliability testing procedures. Right?
Totally.
There is no compromise.
I can vouch for that.
Ceiling fan don't fail. They last for 30, 40, 50 years.
Yes.
So consumer has the same aspiration. But now we are introducing all this electronics, all this programming, all these interfaces. There are more elements in the equation. Very similar to EVs. Right? More elements, more electronics. We were always suspecting that electronics would fail. Of course, electronics can fail, but to make a more mature, sturdy, reliable design, you have to pass all these testing procedures. So we have been investing heavily on reliability and endurance testing of all our products. Right? Without that, the product will not go to the market. And on top of it, whatever we produce, like for example, mixers and grinders, we identified this opportunity that a mixie, a BLDC motor, right? We say that it is a BLDC motor, mixie.
Mixie.
But what BLDC motor is doing in mixie?
For what? For the consumer. Yeah, exactly.
What it is doing? It is no, people are not buying it for energy efficiency.
Yes.
You run mixie for only 1 minute or 2 minutes, not more than that. I think what BLDC motor is doing in this is very magical in nature. Traditional mixie were running on something called universal motors. These motors don't have electronics and control system.
Okay.
You put a stone in the jar, it will grind the stone. Right? You put anything in the jar, because it is a dumb motor, it is not intelligent, it is not controlled.
Okay.
In case of BLDC motor and the associated algorithm and the electronics is able to sense the load conditions, right? And it can deliver very high torque at lesser RPM.
Okay.
And most of your recipes, a lot of your recipes, like if, for example, you are making a chutney, you need a chutney coarser texture. You don't need to rotate it at a very high RPM. So you can regulate your RPM and the torque in such a way that you can do the treatment of grinding with the ingredient differently to meet a better taste, right? Like we have been using silbutter historically.
Correct.
That is one of the marketing thing we do, that you will get a silbutter kind of texture. So it is enabled by BLDC motor. Universal motor cannot do it. You need some level of intelligence in the system and motor controls, and then you are able to deliver better experience of grinding, juicing, right? The other product is a cold press juicer,
yes.
Right? And a very cost-effective, intelligent, and there are a lot of safety features also we put. If a jar is not properly locked, it won't start. If it is overloaded, again, it should set an alarm, because overloading is not good. Overloading could lead to some accident, right? The lid locks are there, so you don't need to hold the jar. And if power is off, for example, many times you just imagine that power is off. You were making some grinding, you were doing some grinding, and then power is off, you will just relax, oh, power is off. But again, if power comes instantaneously, the mixing will turn on and everything will flash out. It will again have a safety feature, it will tell you to go back, reset and start. So these are very minor things which gives consumer a very feeling that this product belongs to us, it cares about us. So that thing is very
user-centric.
Yeah.
User-centric design is the principle which you talk about more.
So BLDC is nothing but one technology which is enabling us to do this, right? So many times people say that, and we don't like to call it BLDC, although when we were starting, we had to convince, because nobody was knowing us at that time. So we have to talk about technology. But I think as we are becoming a larger brand, we talk more about the consumer. We are more about their aspiration. We talk more about the problem solving with them rather than the technology. Because there are so many hidden technologies which are together delivering that.
Awesome.